Here we go, last but not least. This is our Kirchhoffs rules problem. And it's actually the same setup as the multiple choice, but I finally gave you some resistors to kind of work with. So we've got a 10 ohm right here. This one over here is a 12 ohm. And then this one down here is a 15 ohm. And you're trying to find all these different currents. So as I get ready to do this, we've already kind of done the first part, is let's use the junction rule. It tells me that I1 plus I3 are going into the junction up here, junction B, and I2 is coming out. So it's a good first place to start. And if you don't want to use I1 and I2 and I3, use X, Y, Z, A, B, C, whatever. Then we start doing some loops. I'm just going to do the same loops I did before. I'm going to do this one. This is going to be loop A, and then I'm going to do another clockwise one, and then another clockwise one. So I'm just going to keep them all clockwise, kind of create my setup here. So my first loop, I've got 3 plus 7, so that's 10 volts, is equal to, I've got my 10 times I1 plus, I'm going backwards through this one, so I'm actually going to write this as a minus instead of a plus, because I think it's easier that way personally. You can also put in, come on, why won't it erase that little spot there? Let's try this again. Erase. Okay, fine. Then I'll do this, plus a negative I3 times my 15. Then I do part B. That's going to be this loop over here. It's going to be 5 minus 7, so there's going to be a negative 2. And I've got 12 up here times my I2 plus, I'm going the correct way this time, so I've got 15 times an I3. And then C here is the big loop. I'm positive 3 and a positive 5, that's 8. And it's going to be my 10 times I1 plus my 12 times I2. Now there's really no reason to combine these two together, because all that's going to do is it'll get rid of the I3, but you're going to end up with the C, and that's not going to help us. So we have to do some kind of substituting. We have to take the fact that I2 equals I1 plus I3 and substitute it somewhere. I'm going to substitute it into this one right here so I can create a new one. So I'm going to combine these together to come up with a new one. It's going to tell me that negative 2 equals 12 times the quantity I1 plus I3 plus a 15 I3. Then I can distribute that through, so negative 2 equals 12 I1s. I'm going to have a 12 I3, but then I'm going to be adding a 15 I3, so I'm just going to go ahead and add 12 and 15, so that's 27 I3s. So there's a new equation that I can work with. Now we need something that has I1 and I3 in it. Well, the one that has I1 and I3 in it is this top equation up here. So let's take this one and let's bring it down in some fashion. So I have a 10 equals 10 times I1 and then minus a 15 times I3. Unfortunately, these are not pretty numbers, so I don't have a good way of kind of simplifying some stuff here. It'd be nice if I had something a little bit nicer that I could kind of work with, but at the moment I don't. I suppose I didn't even think about this, but I could change this bottom one just real quick. If I divide everything by 5, sorry. In other words, if I factor a 5 out and kind of cancel it, this bottom one becomes 2 equals 2 I1s minus 3 I3s. That might be a little bit easier to work with. Now, I'm going to try to actually eliminate the I1s. I know that seems weird, but rather than trying to work with this 27 up there, well, I guess 27 is just 9, isn't it? So 3 times 9 is 27. So yeah, we can work with that. Let's do that. Let's just multiply this by 9. 9 times 18, 9 times 2 is 18. 9 times 2 is 18 I1s, and then minus a 27 I3. So then I can add this with this one up here. So I've got minus 2 plus 18, so that's going to be 16. I've got 12 I1s and 18 I1s, that's going to be 30 I1s, right? And then 27 and a minus 27, they disappear. That leaves me with I1, divide by 30 here. That's what I1 is. Let's simplify this fraction, 16 over 30. Let's see, I'm going to write this as a fraction as well to kind of see. I know I can take out a 2, but I just want to see if there's anything else. So it does simplify just by taking out a 2. It would simplify to 8 over 15. That's how many amps I have. But I'm a big decimal person, so I would say 0.53 repeating. So there's I1. So I'm partway done. Now I'm going to take that and put it into something to try to solve for another quantity. It doesn't really matter what I solve for. I haven't used this last equation. I haven't used this C equation, so I'm just going to go ahead and do that. I'm going to plug this into this equation right here. And so if I do that, I'm going to write C over here. So that's going to make it 8 equals, I'm going to take 10 times, I'm going to write it as this little fraction here. It was 16 over 30 plus 12 times I2. So that's going to cancel with this, and this is going to be 16 thirds. And then I can subtract that over to the other side. So 8 minus 16 thirds. And this would be what, 24 over 3. So 24 minus 16 is 8. So this whole thing is going to be 8 thirds. That equals 12 I2s. And I can divide by 12. By 12. And I2 is going to be 8 over 36. I know I can simplify that a little bit because I can take a 4 out of both the top and bottom. So that would be at 2/9 of an amp. Let me double check that I'm doing that correctly. We'll use my calculator here. So if I have 8/36, sure enough, 2/9. And 2/9 I know is 0.2 repeating in amps. So now I've got I1 is 8/15 of an amp, I2 is 2/9 of an amp. Now I just have to figure out I3. I personally like to come back to this one because you don't have any numbers in front. So it's much easier to work with. This tells me that I3 would actually equal I2 minus I1. So this is going to be this 2/9 minus this 8/15. Let's see what we get for I3 here. Got 2/9 already in here. Let's subtract my other one, which is 8/15. I get negative 14/45 of an amp. Let's go ahead and convert that into a decimal. So negative 0.31 repeating. Now, why is it negative? That just tells me that this is picked the wrong direction, which I probably would have guessed anyway. This 7 volts really should have driven it down. I should have had I1 going in and I3 and I2 coming out. This is just what they picked for us, so we didn't really have much choice in this. And that is how we solve our Kirchhoffs rule problem. So If they gave you the directions, we would just give us the answers and we're good. If they hadn't given us directions, we would say I2 is going to the right or left to right. I1 is going left to right. And then I3 we would say is going down from top to bottom. That's all I've got. Hope you enjoy, and I hope you're ready for this lovely Unit 4 test.